we've already got a good number of people joined. So without further ado, maybe we just get started. Welcome everyone to this webinar on software architecture, the hard parts, and specifically on one of the harder topics, which is data architecture. I'm Rachel Laycock, and I'm the Global Managing Director of Enterprise Modernization Platforms and Cloud at Thoughtworks. And one little known fact about me is that I actually started my career as a DBA before becoming a software engineer. So the challenges of data have always been fairly close to my heart. I'm joined today by Zhamak Dehghani and Pramod Sadalage. They are going to help us unpack some of these challenges around data architecture. So Zhamak works also at Thoughtworks. She's a technical director of emerging technologies in North America, and she focuses on distributed systems, data architecture, and decentralized platform strategies. She's a member of the Thoughtworks Technology Advisory Board, but she is also the founder of the famous data mesh concept, which is a decentralized approach to analytical data sharing. And she touches on some of those concepts in this book, which hopefully some people have read and maybe have some questions about today. And she has a book about data mesh, delivering data-driven value at scale, which will be released in March. I'm also joined by Pramod Sadalage. He's also a director at Thoughtworks, and he enjoys the role of bridging the divide between database professionals and application developers. He's helped many of our clients on their particularly challenging data needs, which require new technologies and techniques. And in the early 2000s, Pramod created a technique that allowed relational databases to be designed in an evolutionary manner based on version-controlled schema migrations. So, yeah, please feel free to say hi in the chat, but make sure you stick your questions in the Q&A section. So Pramod, alongside this book, also co-authored Building Evolutionary Architectures, Refactoring Databases, No SQL, and he authored Recipes for Continuous Database Integration. So we certainly have a couple of great people on our hands to help us unpack some of the really hard challenges of data architecture. So when writing the book, Fundamentals of Software Architecture, Neal Ford and Mark Richards kept coming across really complex architectural examples that lacked easy solutions and really kept just turning up trade-offs, which is something as consultants we're always dealing with. And they ended up putting those harder parts into a too hard basket almost. And that too hard basket, they later reflected on post the Foundations book to start identifying what some of those key trade-offs were. And that's how we ended up with software architecture, the hard parts. One of those hard parts, many of us, I'm sure, who have joined today are all too familiar with is what about data architecture? What about data architecture in microservices? Or what about data architecture when it comes to analytics? And how do we think about that in modern software architecture? So just a reminder, please ask your questions in the Q&A. Yes, the first question is, will we be sharing the recording? Yes, we will. So the first question I have for Pramod and Zhamak is really, data architecture is a really big topic, and the book isn't solely about that. So how did you decide on the scope and what to cover and what the takeaways were that you wanted people to take away from the book? And whoever wants to go first.
You want to go first, Zhamak?
Go ahead, Pramod.
All right. So in the book, like you mentioned, there's a lot to cover about data architecture, but we are trying to focus, especially as it relates to the distributedness of architecture, right? And within that, two broad areas come into mind. One is around analytics, like distributed stuff analytics, and the other is distributedness, the microservices. How do you distribute your data, and what are the illities, as mentioned in Neal Ford's Fundamentals of Software Architecture book, is how do you handle those and what are the trade-offs and that kind of stuff. So one big area that we really focused on is how to decide where your domain boundaries are. And if you are in a monolith, how do you split them? And if you are in a microservice, like, should I combine a couple of them, or should I keep like splitting them until I reach to a good boundary? And what are the forces that are making you either combine things or break apart things, right? Like there are some things that force you to combine things, like probably notions about like transactions, or probably notions about too much usage and things like that. And there are some forces which try to break you apart. One classic example is scalability. So those were the things we tried to deal with it. And as we went along, we thought, I had done a lot of work around NoSQL databases and which database to pick and that kind of stuff. So we did a section around like star rating database systems as such. And because nowadays, as you know, there's a boatload of choices for database types to be picked. Zhamak?
Yeah, so I think we kind of looked at the macro focus, or the macro umbrella of the book, which was around, decomposition and recomposition, right? How to break things apart at the large scale, and how to integrate them back. And when you think about that, a lot of the hard questions are around, how do I break apart my applications? How do I break apart my data? How do I reintegrate application and data back together? And kind of we followed that thread, and that somewhat narrowed our scope. And we went beyond just, how do I break apart my databases for my applications? And we looked at, well, we are moving, I guess, beyond just applications that are databases that support a particular application. And we're really thinking about how to augment our applications with intelligence, and how to make our applications smarter. And ML is part of our applications. Analytics is part of the story. So we brought the kind of the bigger scope of data recomposition and decomposition concerning kind of ML and analytics as well. But that was kind of the overall guide. So then we didn't really look at, how do I exactly model a particular domain? Like we also stay domain agnostic. Like, how do you model data in retail versus model exactly your entities and relationships in, healthcare? That was outside of the scope of this book. We want to stay at kind of the system level architecture.
Wow, I just put myself on mute then. So you both touched on two kind of really interesting topics. One is this, what does it mean to break apart your data in, microservices from a monolith application? Somebody even put, why do you want to break your application in the first place? So I think I'll come, and ML is another really interesting topic. So I'll come back to that one. But maybe Pramod, you can build a little bit on what you talked about. Moving from a monolith to microservices, like how do you think about your domain boundaries for the data? How do you split the database? And somebody even asked the question of why.
Yeah, like I think the question of why is important to be answered. As our monolith gets different usages, the business changes, the type of scale requirements or any other stuff, like probably your users were all in the same office. Now they are distributed all over the world. So responsiveness matters, a bunch of those kinds of forces that are acting in your business makes you to think about, like, for performance sake, for scalability sake, for availability sake, all the utilities in the architecture, maybe it makes sense to break apart. And when we mean break apart, we don't mean like you're literally going from one monolith to hundreds of microservices. That's not what we mean. Maybe there are some functions that need the scalability while others don't. Some functions need availability while others don't, and that kind of stuff. So look at what needs you're trying to do, and then try to break that apart, right? Or extract it away from, and there are classic patterns like triangular pattern or other patterns to do that. So once you arrive at a decision that, okay, I need to extract something out of this monolith into a microservice, then the decision comes down to like, okay, how do I go about doing this, right? So one point that you need to do is like the software wise, how do I break apart the functionality? And for the user, how do I integrate it back together so that for them, the usage experience doesn't change or maybe is better and things like that. At the lower level, the bigger question comes is, how do I break apart the database itself, right? And most of the times, if it's a monolith, we have ended up into this classic integration pattern, known as database as an integration point, right? Like some processes put data into a database and other processes read the same data from the database. And we have this coupling that happens at the database layer or in the database. And when you break apart something, then the thing that puts data into the database still needs to put data into the database, and the thing that is reading data from that database still needs to get that data. And if these things are in separate databases, now we have a disjoint functionality, right? So to keep the functionality going, you have to have a methodological way of doing, like breaking apart, right? So in the book, we came up with like a 5-step process on how you can think about this, right? Like first, the notion about like understanding your domains, like break apart the domains. Like, can you look at your monolith and look at the functionality that needs to be broken out? Like, let's say, for example, you're trying to extract your customers and orders, because orders scale a lot and customers don't. So maybe you're trying to break them apart. Or sometimes it could be even like pure technical functionality, like searching, for example. Many architectures we see where like 98% of the load on the system is coming from searches, because users are searching for products or whatever other stuff. And the rest of the system doesn't need to scale for 98% of the load. Probably you can take away the search, put it somewhere else, and then let that happen. So let's take that use case, like, okay, I'm splitting apart for the sake of search. So when you say that, all the product information that is going into the database, like writing stuff, still need to go to the original database, but some of it still now needs to go to this other service that you built for searching and things like that. So there's this notion of like data synchronization. How do I split? Where do the search? Like the original application probably was calling like a view or a stored procedure, stuff like that. That now needs to call an API that is sitting in front of probably a search engine like Elasticsearch or Solar or something similar. And then now you need to like ensure that all of the searches are great. And then you also need to deal with the notion of like eventual consistent data. Someone updates a product. When does that data reach the search side of the architecture, and like a bunch of trade-offs that you have to discuss and deal with. But at some point of time, you'll end up into this architecture where search is totally being taken care of by outside API. And like the 5-step process helps you deal with that. Along the way, when you're splitting, the microservice that now owns this data, you can now decide what kind of database do I need for this particular microservice. In a monolith, because you were doing all kinds of different types of functionality, probably you went with the lowest common denominator or the default choice being a relational database, and you went with that choice. Like in a microservice, because you have very targeted functionality that the microservice is implementing, you can probably pick the right kind of database for that particular situation. And it could be a search engine, it could be a graph database, it could be whatever else that makes sense. So that's how like generally the flow of that is in the book, and that's based on like a bunch of experience on implementing those patterns.
I want to double click on something here. I think you know, a lot of the times as engineers, we are driven to decomposition, recomposition by the technical needs. As Pramod gave the example of optimization of search and scaling search independently to scaling something doesn't need that level of, you know, CPU intensive, or scaling databases with massive parallel processing and sharding of your databases. These are very what I call optimization for the machine, right? We're breaking things apart to optimize for the, you know, CPU, disk, and the machine architectures that we've built. But there is another piece that's really important, which is optimizations for the human and for the human experience. So, you know, the reality is that we are collectively, or as organizations, we are a very complex human system. And we sometimes forget that optimizing architecture for the experience of this complex system, as we have different teams, they work at a different scale, they have different or speed, and they have different incentives, and sometimes they don't talk to each other, sometimes they talk too much to each other. Like every piece of organization is moving at a different speed and scale with some local incentives, some shared incentives. And when you want to get optimized for this global complex system of people to achieve these some shared and some individual objectives, that has a massive impact on our architecture. And I feel like with the wave of kind of the microservices and containerization, that wave of kind of architectural change was one of the first time that we really looked at this human system and said, okay, well, the teams are independent, they have different motivations, the smaller teams, integrating through APIs and loosely coupled, give autonomy to people, right? Autonomy, mastery, purpose, like these are human incentives. And microservices has started to bring that conversation in and creating an architecture that was aligned to that human system. So I think we are in the data space, I feel like we've somewhat neglected that, and it's time to kind of optimize for humans, of course, without optimizing for people. I saw an example there, like how about latency, and of course we don't want to compromise that, and there are ways of avoiding to compromise that, where we don't want to forget about the people.
Yeah, it's interesting. I think, a few years ago when I was doing talks and workshop on microservices, I used to absolutely dread people asking me about the data side of it. Not because I didn't have some answers, it's just that it was such a big "it depends" answer. And it certainly added complexity there. But, when you're talking about creating these more human orientated systems, it's a complexity. It comes back to that trade-off, right? It's a complexity you build in there for a purpose, right? You don't just build in complexity for no good reason. And I think one of the things, we've talked a little bit about the creation of systems and the creation and the transactional data. But one of the things that was definitely neglected, in my opinion, was the analytics side. We all know the history of data warehouses, which was very, very centered on, optimizing for the machine, and was just impossible to write queries on. I was one of those professionals who had to write those queries, and it was incredibly complex writing some of those queries for the data warehouse. And so we moved towards this data lake thing, which at first seemed like, okay, great, but let's just put it all in a great big data lake, and we'll figure out how to, we'll push the problem, I guess, kick the can down the road of like, who's going to figure out what's the right schema for analytics. So, even with the data lake approach, I still think there's this huge divide basically between the data that we're creating, the transactional data, and the data that we want to build any reporting off, and that has got even more complex with microservices, because now we're introducing lots of new data types of technologies, different ways of thinking about the data. How do we bridge that divide?
Yeah, I think there are a bunch of divides that we need to reach, right? I think we again, going back to the history of like the evolution of architecture and technology over the last and organizations over the last few years, we have brought down a few walls. We brought down the divide between dev and ops, and we've got one big divide to break down, and that's this. I build application, you build ML, or you build analytics. Right, the divide between kind of this application-oriented data and data modeling and data technologies and infrastructure, even like the full stack is kind of divided from people down to the bottom of like the technology, and the divide between, well, I'm just going to dump my stuff in my application database. My application database is optimized for me, for responding to the end user that's clicking, buy shirts or add shirts to my cart. That's what it's optimized for, very rightly so. And analytics team, good luck with that. Come and write your ETLs, get it, dump it to the lake, dump it to the warehouse. And then, you have the data teams on one side pointing fingers to the application teams, and application teams pointing fingers to the other side, when this kind of massively complex integration engine that we've built in the middle with this kind of labyrinthine forest of pipelines break, and nobody knows why it breaks. So something upstream changes and the downstream changes. So I think we really have to revisit that. And again, the driver to revisiting that reintegration and reconnection of these two worlds is that the dependencies are becoming tighter and tighter, and there's a feedback loop that's being created. So in the past, before the rise of ML, before embedding analytics or analytical decision making into everything really you do, from A/B testing of the little button that you change on the screen to adding, optimization with ML or recommendation personalization with ML, right? That is changing. So before this happened, what did we have? We had application databases that were optimized for the microservice or application. And then we had a bunch of reports, right? Reports on KPIs, or maybe we had very specialized areas of kind of statistical analysis of, what we do, or fraud detection, or very, very, very few specialized areas that needed kind of data across those applications to bring them out in models. And they were mostly driven by reports that a human sits in front of and read and analyze, right? But that has changed, right? Now we need to kind of get this data, not only to just one or few reports or few niche areas, the data-driven areas. Almost every one of those applications can be and has aspirations to use kind of ML or analytics somehow to optimize how they serve the users. And those ML models or those analytics need data from across the organization, right? Not from one place. So this closing this loop and people becoming, those application developers becoming kind of more data aware, and our aspirations and number of use cases kind of growing from reports to now applications, and also the sources where the data is coming from growing. It's not one or two systems. Almost every single touch point has a digital experience that is generating data as a byproduct of running that experience. So this becoming really complex. So we've got to divide that analytical versus operational, two sides of the organization, two separate stacks and pipelines in the middle. So it's a natural organizational complexity that deserves a very different look and a very different stack, full stack, from the human at the top to the bottom.
Yeah, I think
what it is, but we can get to that in a minute.
Yeah, and to add to what Zhamak is saying is, like maybe a couple of decades back, right? The value people derived or enterprises derived from data was not there. Like data was just like transactional purposes, record keeping purposes. And now people have figured out a way to derive value from data. And it could be transactional data. It could be what users did on my website data. It could be like what the IoT devices are doing, and all kinds of data. You can derive value from it. And that puts an extra impetus on the amount of data we capture, where we capture it from, how we process, and how we bring it with extra additions of like ML, AI, statistics, visualization in front of users, in front of business, so that we can derive more value out of it. And I think that emphasis has changed the way we think about data, right? And that's why data that was somewhere like the DBAs dealt with is coming more in the front, where architecture has to deal with it, where businesses have to deal with it, and you have to deal with that. And because of the volume increase, we can't put it in a single data warehouse anymore. It has to be that fits. Like the data doesn't fit in a single machine anymore. So you have to come up with a larger set of architectural guidelines to deal with the data.
Yeah.
So, sorry, go on, Dimash.
There are questions coming in some of the chat to really drill into the house.
Yes, I think the next question is really the how, and I think there is a question that's specifically about how do we model certain things on a mesh. How do we do it basically? Like having read the book myself, there's these concepts of data products, but it's still quite abstract in terms of like how do we do some of these more challenging transactions on leveraging the data mesh?
Yeah, I think data mesh is first and foremost is a kind of both a human system as well as a technical system, an architecture system. So and really discusses recomposition and decomposition of data at a logical level. So there was a question there that, I have, how about latency? How about, locality? There are really practical, physical, what I call physical level kind of questions. And data mesh doesn't dictate your data shall be pulled apart and put into different databases to be, independently decomposed. So I just want to make it clear that at a physical level, we can do all of those machine-oriented optimizations by considering where actually physically data lives. But at a logical level, when we think about teams, what data mesh tries to do is to say, okay, over the course of any organization, when you look at the history of your organization, if you're a complex organization, if you've grown over the last few years, your organization has started pulling itself apart into more focused areas that we call a kind of domain-oriented digital organizations, right? You have different business domains, some dealing, if you're a retailer, some dealing with logistics, and some dealing with planning and, assortment or e-commerce. These are business areas. And to support those business areas in your digital journey, you have created digital applications, e-commerce application, order management application services, and so on. And some of them with microservices, some of them with legacy systems. And you have stood up, again, if you are a modern digital business, what you've done is you've stood up technical teams, application developer teams that are supporting and enabling and expanding, or improving the operation of those business units. What data mesh says is, again, is it possible at that logical architecture level to align sharing data for analytical use cases, which is different and still from transactional use cases, as in you're optimizing for larger queries, you're optimizing for almost no updates, mostly reads. There are different optimizations. Is it possible to create this kind of collaborative, we call them architectural quantums, collaborative, we can talk about what's a data product as an architectural quantum that essentially their job is to externalize responsibly the application data, as well as the metadata around that, the documentation, whatever helps understanding and trusting in that data, right next to that application by the same team, perhaps extended with a few people to focus on that, and share that responsibly in a way that the collection of these kind of domain-oriented data products can enable distributed analytical workloads and sharing data in a peer-to-peer fashion without requiring to, as you said, kick the can down the road and give it to a data team to now put it somewhere so that we can run analytical workloads. So that's kind of the high-level approach that data mesh takes in terms of thinking about how to logically architecture the data sharing for analytical workloads by domains right there and then where the action is happening, by the people who know that data and that domain most intimately, by the people that control the life cycle of that application database, which again, it's the source of the data anyway, and work with those people more collaboratively and yet have kind of API driven or ways of sharing that data. And if it follow that thread of thinking and that thread of implementation, then you will arrive at a new architecture quantum. We call it data product. Again, data product is one of those words that it's just a lack of, or the data quantum, data product quantum, for a lack of any other words that describes this concept we use, this may not be the best word, but in data mesh, what it means is recomposition of compute and data. So we are recomposing the code that transforming that operational transactional database to an analytical data. We are including code that is sharing metrics around timeliness and quality of the data to help trust in data, to help establish trust. Is this data the right thing? And we are recomposing, kind of the metadata around understanding, schema of the data, anything that needs to evolve with the data as well. So we're recomposing code and data again, but very specifically for running analytical workloads.
It's a very different way of thinking about data because of that really distinct divide that we've had for a while. But somebody's asked specifically the question around HTAP, whether it being a positive or a negative anti-pattern. I mean, do you think is this what you're explaining, or is it a different thing altogether?
I think I am not being, even though I'm personally an idealist, I'm not that much of an idealist. I'm also have a little pinch of pragmatism in me. I think there's universal solutions, and I've heard, I don't know, some one of the big tech firms actually working on it. This at the technical level, creating a technical solution that can not only satisfy many tiny transactional updates as without disrupting, and also, running this big parallel massive writes and massive aggregates at the same time without either disrupting the other. At technical level, is it possible? Does it exist? I haven't seen one, but maybe we get there one day, right? Maybe at some point we get there. What data mesh actually does, it kind of sits in the middle. It says, first of all, I don't care at the physical level what we're using, but at a logical level, a human will have a very difficult time, a person, a team, to focus on both. Rachel came to the website, or customers come to the website, and I have to satisfy their query or the request for buying a shirt or buying a pants, and building an e-commerce to give the best personal experience to my customers. And that's my focus. And at the same time, I'm focusing on satisfying the data analysts and data scientists that are working with me closely, and trying to collect all the data that they need and make meaning of it, and create features that train their machine learning. In fact, it's very hard to do that by one person. So even if at the physical level we say, oh, I'll buy this magic silver bullet technology that does both, at a human level, I think for quite a while we'll still have these two roles and two responsibilities. And again, if you follow the human kind of thread of decomposition, we very likely will have two collaborative. We use this term collaborative as showing these are separate, but yet closely coupled and integrated. In fact, when I was writing this upcoming data mesh book, I talked to the team topologies folks who wrote this wonderful work off the back of research and working with a lot of teams. And they kept correcting me and saying, look, when you use the word team, in fact, you have to be very clear as what's the intention and objective of this team. So maybe you're talking about multiple teams that are working together. So when we talk about domain team, like an e-commerce team, within that, there are probably multiple teams, because they both have very different incentives. They wake up in the morning satisfying a very different user, right? They're getting satisfaction from creating value for two very different personas. And until that, I don't see that they disappear or that changes. So until that's how we operate, I think there is still a separation at the logical level between analytical and operational.
Yeah, I was going to say, I think and I want to lean a bit more into the logical level, because it comes back to that hard trade-off, right? We're still going to have to make trade-offs around what we actually want to, how we want to use the data, and the fact that we have, become much more data-centric organizations, and everybody's trying to get better insights out of their data. At the same time as we have these new architectural patterns and new data sources coming in, adding more complexity. And it doesn't change the challenges of like why we've chosen the physical architecture that we have. And I think in the past, we've been very, very led by the physical architecture. And now there's this push from the other side of like, we need to do more with this analytical data. We need to be able to understand it in different ways. So I want to lean a bit more into the logical stuff, because I feel like going into the physical is a bit of a rabbit hole. But there's a couple of questions about things like the machine learning models and the data, and how do you ensure in these new like logical ways of thinking about the data, how do we ensure it's not biased? And then how do we think about things like GDPR in Europe and privacy? Because one of the issues with data lakes is you just dump a ton of data in, and then it's kind of easy to break PII. Because you can join data up and figure stuff out that you might not have been able to when you had a very, strong schema approach. So What are your thoughts about that?
Yeah, and Pramod, please chime in as well, because I know you
Sure. Yeah.
saw some of these problems. I think what I'm really excited about, this concept of which we only scratched the surface, the concept of creating these autonomous, well-bounded, well-protected, domain-oriented data products that both include the code, the APIs, policies, and the data. I think that, again, it's another mind shift. In the past, the way we thought about data is that data is this passive thing, right? It's passive. An active application, an agent, like an application, dump it somewhere, and then, it's at the mercy of whatever other agent or application to come and get to it, and there is no protection around it unless you create these technologies or layers to protect it. What data mesh is introducing, and it's still is in infancy and we have to evolve it, is that data is no longer passive. No data will be shared without an active agent that is imposing the policies, that is kind of protecting the data, that does encrypts the data, decrypts the data, it evaluates who wants to access it and when and where. So there is an active component to the data. I just kind of imagine it to get a little bit romantic here, the separation of body from the soul. I felt like for a long time we separated the body from the soul, like we put the data somewhere and the soul from the data, and we kind of need to reconnect body with the soul. And in the case of data products, there's always an active code that that for every access, for any connections, for every request, right then and there at that end point of access to data, the policies get evaluated. And what gets shared, if you're kind of sharing that data, somebody's making a query, and finally you say, okay, I've enforced all of the policies. I look at the locality where the request is coming from. Can I share that data with them? Or a subset of the data based on the query that they're evoking on your database. What you're sharing with them, again, is not just the data itself, is the data carried with the policies and the linkage back to the original policy. So I guess what we're sharing is to share data responsibly. We can't just share the bits and bytes that are sitting on the disk. We have to share a little bit more linkage back to the policies, linkage back to the schema, linkage back to the original source. So and then there is still work to be done, and there is no single product that today you can go buy that does all of that. But I think that's a shift that, at least that's the approach that data mesh is taking. And I know in social media and other places, people kind of a little bit confused and say, oh, data is not code anymore. And it's actually data and code together that is the unit of exchange that we're sharing around.
Fascinating.
I think to add a little bit to that discussion, like if you think of like a service that is giving you some capabilities, we can think of it as the capability of analyzing data or providing policy of data like protection. You can think of like policy of encryption, or you can think of like statistics applied to that data. That's other capabilities the service is providing, right? So you can think of it in that way. So then now the same service that does something, you can think of, and the service doesn't necessarily have to be like, I mean, what is the size of a microservice? That's a whole different discussion. But within that service can provide you some capabilities, and the other capabilities that, because it is closer to data, it can also provide is these other things like policy, like data governance policies that get applied on top of like requests, or it could also be encryption. It could also be like machine learning models applied to the data. It could also be like statistics applied, some other types of statistics, aggregates, a number of other things that same service can provide. Instead of shipping the data somewhere else and then making those policies run on that copy of the data, we are saying work with the same data and you can apply these different policies, different types of things to it.
Yes, and there is a trend. In fact, I've talked to kind of hardware providers that are from scratch building new hardware to, instead of trickling data to your CPUs to then run a massive, kind of processing where your processors is like sitting there waiting for the data to arrive, you are moving the computation to the closer to the data. So again, that's a physical level, movement that is happening kind of by the next generation hardware. But at the logical level, again, thinking about the people and the policies, that works nicely with the concept of data mesh, because we're creating is the idea of like output ports for different modes of access to the same domain-oriented data. And one of those modes, you can bring your query, bring your SQL query or whatever query you have to the data product, and the data product has a computational kind of capability to run it, or even bring your ML to it. And if you're using at a physical level BigQuery or something like that, that convergence is also happening. Like BigQuery extended is SQL to run not train ML models on it. And if you're following the trend of federations, like the federated queries, while their birth was created by a different demand, by the messiness of data residing in many different technologies, but they're very much evolving to suit this kind of run your computation closer to the data, impose policies right then and there, which is very much aligned with zero trust architectures. And then, and if you are creating a new data as a result of that, because you're just downstream creating insights, that itself become a data product. That itself will have all of those capabilities around enforcing policies, including policies and including the computation that protects that data. So that's why it's a mesh. So you can kind of create as many data products as you want without compromising kind of security and policies.
Yeah, and it's the sidecar, from my understanding, that's really the critical piece of that. In fact, I think there's a question in here about like, how is it different from the data lake? And I think the data product is really the answer. Like, you kind of do a deep dive and understand what the data product is and how that is adjacent and coupled to the normal domain objects that you have that you're creating to create your microservices. Then to me, it is quite different from the standard data lake of just dump it in and let somebody else figure it out later. But it does bring up one of the earlier questions of, does this mean that data architects suddenly need to have an understanding of domain-driven design? Because that's a whole thing.
Yeah, and I would say, like, having worked, like even my bio says, I'd like to divide, like, I like to operate between the space of data as well as developers. And the answer is yes, because as enterprises get more complex, right, understanding the domain, understanding where the domain split, understanding what kind of data lives in what domain is really important for the data architect, the database people. Because where it fits in the domain, what type of storage that domain needs, what type of architecture that domain needs could be different based on what kind of domain problem you are trying to solve, right? Like something that is doing like logistics is not the same as something that's doing probably like search optimization, right? It's not the same. And then you probably need to understand what are the intricacies of the domain, right? So then what that does is makes you more productive while you're conversing with the business people as well with the software architects, right? So I think we need to reduce that space, and the more data architects get comfortable with talking about and understanding domains, the better it is for them as well as for the organizations.
Yeah, and then there is a question from Martin Jones on kind of what's the difference between subject orientation and domain orientation. I think, again, subject orientation comes from data modeling. Again, it's a kind of a bottom up. Let's look at the data model in itself. And you can do subject orientation in a closed room in a lab environment. Go look at an organization, the type of data that they're generating, and close the doors and go on a whiteboard and create a subject-oriented data modeling, and it looks beautiful, and you can do normalization or denormalization and run all sorts of wonderful queries on it that has no or very little correlation to the reality of how the teams and people organize themselves. So I think the domain orientation, while it has overlap in many cases with the kind of the subject orientation, like the subject of, product, or the subject of sales items, or subject of, orders. When we look at what domain orientation does, it kind of looks at the business and how business and teams are organizing ourselves, what the communication structure looks like between these business and teams, and then looks at the technology that is serving that business and the kind of domains and bounded context that exists within and at the boundary between these domains, and then arrives at the model that best serves that function. So I think domain orientation perhaps is the gap between, fills the gap between this kind of very subject oriented modeling of the data and the organizational and business driven kind of modeling of the data and applications.
Martin asked another really interesting question about like the provision of these data products to consumers, and what happens when a consumer stops providing the provider stops providing these data products to consumers. Like how does the system, or how does the architecture support that?
Yeah, and the reason we called this a product was that we wanted to really bring the emphasis on the attitude toward data sharing, really, put a focus on this product thinking side of it. If data is a product, the consumers of the product should be the first and foremost, the most important thing for the providers, right? The providers have a responsibility to those consumers. Of course, they have to work with those consumers closely, understand their needs, understand who they are, their suitability, whether they should be using this data or not, they should be served or given access to the data. But once they get to an agreement and the data is provided to the consumers, then there is a long tail responsibility around kind of how to support versioning of the data, the change to the data. How do we support retiring that and gracefully perhaps moving the consumers to somewhere else? So there is a long tail kind of, that's why in fact we call this like kind of long-term ownership of the data, right? So that you have an accountability to those consumers because they're using their products. You can't just willy-nilly, change your schema without thinking about the impact of that. And managing change, for example, is a really big topic. I scratched the surface in the upcoming book, but it has to be the one of the most important things that we have to think about is how do we treat change? Is change to schema or to the data is an exception? We treat it as an exception, and we try to put some versioning around it, or we treat it as business as usual. Everything's changing constantly. So let's introduce a system that change is completely built in, and so that we set that expectation with our consumers. How do we communicate change with them? And again, this is a very, very deep topic, so I'm not going to go into it.
Yeah, I mean, this whole thing is a huge topic. You can tell by how far-stretching the questions are. Everything from physical architectural challenges to how do I design my microservices. So I think one thing that might be helpful, actually, because we talked about data products a few times, and somebody's asked, can you give maybe an example? And I'm sure in fact I know you used an example in the book, but kind of summarizes or articulates some of what you've said in terms of like the domain and the data product that might help tie it together for people a little better.
Yeah, sure. In the book, I use this kind of fictional company that does digital media streaming, because I wrote the book listening to digital music and streaming music services the whole time. So if you imagine you're in a Spotify or your Pandora or Apple Music or any of those, your business has a certain functions, and one of those functions could be, for example, playing different playlists for music playlists, right? So you have a team that is working on creating, curating playlists, but one of these, some of these playlists are actually data that's generated from machine learning models, right? So recommended playlists could be a data product, Monday playlist, Sunday playlist, playlist for running, playlist. And these are, again, this is not a single playlist data set, but it's lots of playlists for a lot of people, personalized for classification and cohorts of users. So it's a large scale data, it's a playlist that's kind of evolving over time. It's not the playlist you listened to last week, it's not the same playlist you're listening today. So you can imagine that as a data product. What's in that data product is actually an ML model sitting and making recommendations and creating these data sets that then your music browser application or music player can come and pick and choose and play for the users, right? Or if you are, let's say you're a podcast department and you are in charge of releasing podcasts and releasing new episodes or onboarding a new podcast host. So this is the function of your domain. You probably have a few maybe micro front ends, few microservices for creating podcasts, releasing podcasts. But on the other hand, your marketing department or your sales department is very curious about the demographic of podcast listeners. How many people listen to podcasts over the last month? What podcasts are the top daily podcasts? What are the kind of the predictions, regional, listeners. So this kind of analytical data products would be, podcast demographics, podcast listeners. So these are just, and you can structure them differently that give you this historical view over all of the podcasts that have been played, the listeners that I've listened to, and the over a course of time and across all of your regions. So these are kind of the larger scale data sets that are useful for analytical purposes, understanding who's listening to podcasts, like some of the simple questions that you may want to answer from those data products. Inside data products, of course, there's code that's generating these aggregated views, and there's code that perhaps, cleansing or modeling the events that are coming from your podcast applications to really make it suitable for a multimodal access, suitable for running SQL queries, running, ML workflows on your columnar files. So it's just, there's a lot more going on, of course, mechanically underneath, but from domain perspective, you can imagine podcast listeners, podcast demographics, that would be some of your data products.
Wow, there is just so much to cover in this topic, and I'm reading the questions in the chat, and we are running out of time. But one of the things that the questions that I think is really interesting is around the cultural change that's needed to create more ownership organizationally around data. So, I think we're all very familiar of when it comes to data, things that get thrown over the wall. You've got one side of the house building microservices. You've got another side of the house dealing with the physical architecture of the data store and how do we ensure that the transactions are moving fast enough and the data is moving around fast enough. And then you've got the data scientists trying to create and run models. And really what data mesh is trying to solve for is to try to bring some of that together and bridge that gap. So this is a question for Pramod. One of the things that you've prided yourself on is bridging that gap. So what do you think needs to happen to bring in a bit more of a data culture, for want of a better term, into an organization, so that we do have ownership and less entropy in the system?
Yeah, I think we can think of that in multiple levels, right? Like one is at the business context level. Do the data architecture as well as the architects collaborate to deliver a business outcome, right? The more collaboration, the better understanding. And that's where I think the understanding of DDD concepts would be really helpful on the data side. So that at the architecture level, collaborating and delivering a business outcome. Then at the lower level, like collaborating with application architects on how to deliver certain things, where are things available, like even in the context of a data mesh or a microservice, like knowing where data is, how can I get it, what is the most efficient way to like deliver it, collaborative approach on delivering a solution. And again, going down one more level, like at a developer level, how can I like collaborate with the developers, right? Like many a times there is this mismatch on what the data layer can do for you and what do the developers want to get out of that data layer. So if you can collaborate effectively so that again, like productive solutions can be put forth is really important. So across the board, like these three layers that I talked about, collaboration is the key, right? Understanding how to like understand the other side. Many times we see divides between like a developer does something and the data people do something and stuff gets thrown over the wall, like, hey, do this for me. And the question comes back like, why do you want this and that kind of stuff. That's not good, basically, right? So collaboration will reduce that barrier, transfer knowledge, right? A lot of times there's a lot of context in what the developers are asking or what the business is asking or what the architects are asking. And at the same time, there's a lot of hidden skeletons in the production data, and people should know what they are. Like how did we get there in the first place? What are the volumes that volumes of data that we are dealing with? What kind of requests are coming on the data side that the data people are serving up, right? Understanding those two will lead to a better organization that can deliver better data architecture, deliver better data products, as well as deliver better productivity.
You posed the question, Rachel, as people are on one side of the house and the other side of the house. Let's bring the walls down and put them in the same room. As Pramod said, you know, it's just getting people work more closely. And there is an anti-pattern that I'm seeing in the industry, and I know I'm gonna upset a few people by mentioning this, but because of these gaps, because of these walls, we end up creating a whole set of intermediary broker roles and titles, like analytics engineer, ML engineer, like, you know, and it was really interesting. I was talking to one of our teams, and we have this, you know, fantastic kind of offering called CD for ML, or continuous delivery for ML. And this client of ours, and the whole idea is that data scientists and engineering work together. Data scientists start understanding some of the basic kind of programming tooling that exists to write their code in a way that can survive outside of the lab. And we were hired by this particular client where data scientists is still separated in that other side of the house, and we're doing CD, continuous delivery for ML, by hiring continuous delivery for ML people on the other side of the house, you know, and then we hire people in the middle. We call them the ML engineers to bridge the gap. So I think some of these divides and some of these intermediary roles that we are creating, that increases that handover to now 3 different roles along the way, needs to go away. We are at the, you know, age that's in our evolution of technology that we can't ignore programming as one of the fundamental skill sets. And, you know, I talked to some of the kind of professors at the university and said, to get to the point that you can program today, actually, there are very little courses you need to take. Like, we are, with abstraction of the tooling that we have, it's becoming easier and easier for people to get the basic, you know, engineering skill sets or programming skill sets, to be able to speak the same language even, and live in the same room in the house, understanding each other.
I love it. We end with something controversial. Everyone needs to become a programmer. We are at time. This has been a great topic. I see lots of people in the chat asking for more topics like this. I think we could break this up into probably 5 different separate talks and several books. But I appreciate the time from Zhamak and Pramod to talk about the hard parts of data architecture. Zhamak's book will be released in March. This book that we're talking about, it was released in November, and there's several sections that Pramod and Zhamak wrote. So I recommend everyone reading them, and hopefully we will be back with more webinars soon.
Thank you for hosting us, Rachel.
All right. Thank you.
No problem.